Hi, this is Paul. We are doing Leetcode must-know interview questions. Today's challenge, course schedule 2. Yesterday we did course schedule 1. Uh, here's the challenge. This is medium. Let's see. There are a total of num courses that you have to take, labeled from 0 to num courses -1. As I mentioned yesterday, this is hard to understand without seeing an example, but we'll see one. You are given an array, prerequisites, where prerequisites at I equals A sub I, B sub I, meaning that you must take course B sub I first if you want to take course A sub I. For example, the pair 0, 1 indicates that to take course 0, you have to take course 1. Now, we can't see the method signature completely here, but there it is. So the input is, first of all, the number of courses that you have to take and a prerequisites array. We'll get a look at one, to see how it works. Let's see. Return the ordering of courses that you should take to finish all courses. If there are many valid answers, return any of them. If it's impossible to finish all the courses, return an empty array. Okay. That's not really an interesting example. Oh, here, you know what? Here's a better example, actually. This is better than the example yesterday. Okay, here's what the prerequisites look like. So you got to take 4 courses, 0, 1, 3, and 2. Again, we're going to use what's called a topological sort here. Topological sort, so each class will be a node in a graph. And we're going to have a directed edge between every prerequisite and the course that it's a prerequisite for, course or courses. So a topological sort means that you sort the nodes in an order such that any node that has a directed edge to another node will come before that node in the sort. So let's see. Yeah, so let's look at this. Where is all right, so if I had a pen here. All right, so the prerequisites. So to take course 1, you have to take course 0. So let's say we have 0. We have to take that prior to taking course 1. We also have to take 0 before taking course 2. All right, put 2 here and another directed edge to 2. The next prerequisite says before we take 3, we have to take 1. So we'll put 3 here. We'll have a directed edge to 3. And then it says before we take 3, we have to take 2. All right. So then we'll go like that. What is a valid topological sort here? It says, well, one would be 0, 1, 2, 3. And that's correct because there is no node in there that comes before its prerequisite. I say prerequisite, we're talking about classes, but every node that has a directed edge to another node comes before that node in the sort, or 0, 2, 1, 3. That works as well. So the thing about topological sorts is, if you have something like 0 and 1 and 2, put the 2 here, and then the 2 has a directed edge. What can you do with that as far as a topological sort? Could you do like 0, 0, 1, 2? No, it doesn't work. 0 comes before 1, 1 comes before 2, but 2 also comes before 0. In other words, there's a cycle. That's what we don't want, is cycles. And you can't do a topological sort on a graph with a cycle. So we use the topological sort, And if we can't do the topological sort, then we know that we don't have a cycle. This is really the same problem as yesterday. To me, it's exactly the same problem, except that yesterday, all we had to do was return true or false. Can we do can we take all the classes or not? And today, what we need is to actually return a sort. All right. So yeah, let's look at an implementation. All right. I think yesterday I may have gone into more detail about topological sorts and some of the intricacies or some of the details of the problem. But because it's the same thing, I'm not going to do it again. But I really think that if we just took here's the solution from yesterday, and I think if we use this solution, we can use it almost as is, right? What do we have here? Yeah, let's try and paste that in and just make some modifications. All right. So let's see. All right. We need we need some data structures to be able to do this. First of all, we need the graph. So we're going to represent the graph as with adjacency lists. So we have a list of integer lists. Each integer list is a two element list. No, I'm sorry. It's not a two element list. So each index in the graph represents a course, and if that course is a prerequisite for one or more other courses, then those courses will show up in the list. So that's the adjacency graph, and that's the first thing that we do is set up the graph. Initially, it's empty. We also need an array to keep track of in degrees. In degrees is how many directed edges are coming into this node, the node at this index. All right, and now we can fill the graph and the in degrees array. So for each prerequisite, which is a two element array, the first okay, wait a minute. I think I got it backwards again. The course, the get prereq as no. I got it right. Okay, so the course is the first element. The prerequisite is the second element, and what we're going to do for the graph is get the adjacency list at the index of the prerequisite and add the course to it. We are also going to increment the in degrees of each course. All right, we need a queue for the topological sort. So we declare the queue. We start with any nodes that don't have any in degrees. In degrees is 0. There are no edges coming into that, so we can use those right away. We would like to eventually get all of the in degrees to 0, and that means that we can do the sort. We're going to keep a count of the number of courses that we're able to process, and actually for this one we're also going to need an array that returns the sorted elements. So the previous challenge, we just needed true or false. Can we take all the courses? This one we need an ordering. So we'll use that. Let's see. While the uh, okay, okay, right. So we have all of the nodes that have no in degrees. They are currently in the queue. So while the queue is not empty, and you know, if in fact there are no um, there are no elements with no in degrees, then we're going to fail right here. But while the queue is not empty, get the course, current course, queue.poll, and let's see, order. So we declared order as an array with a length of num courses. All right, yeah, we can do that. And actually for processed courses, um, think about that for a second. No, we can do that. Okay, so poll the course, and then we'll say order of, processed courses is not such a good name anymore. Um, let's call this something else. Let's call this course count, and we'll use that. And we'll say order of, we'll use course count as the index, and we will also increment it. But we can do that at the same time. So basically this line here, we're going to combine it with this. So the order of the course count is course. All right. So anyway, DQ, the first course. Increment the course count, add the course as the first element of the sorted order. All right, for all right, hang on, I gotta think about this for a second, how to modify it. Okay, no, actually, I think that's going to be fine the way it is. So, neighbors, we are going to get the adjacency list for this course, meaning uh, all of the courses for which the course that we just processed is a prerequisite. We are going to reduce the in degrees count of any course that has this course as a prerequisite. If we have decreased it so far that it has no more in degrees, meaning all the prerequisites have been satisfied, then we can put that in the queue. We are going to do this until the queue is empty. We are going to return. We changed the name of that. So let's do this. Course count. All right. If course count equals the number of courses, then we're going to return the order array. If that is not the case, what are we supposed to return? I think an empty array, right? So it says, if it's impossible to finish all courses, return an empty array. All right, yeah. So if we somehow manage to drop out of this loop without completing a full ordering of courses, we'll just return an empty array. All right. Let's run this and see what happens. All right, accepted the basic cases and submit. Later. Oh, you know what? We did better on the time this time. I don't know why. It's like yesterday we were kind of like over here. We were on the it's still kind of a bell curve, but we were just to the right of the peak of the bell curve, and today we're on the left. I'm not sure why. I mean, there is more than one algorithm to do topological sorts, so I just thought, well, maybe the one we're using is not as fast as some other ones. But today we are actually ahead of the curve. Oh, wait. Oh, I didn't mean to click that memory. All right, and runtime. So that's it. That is course schedule 2. I hope you enjoyed that. And feel free to like, subscribe, comment, and see you next time.